Okay, somebody asked how to do number 4, so here we go. So remember, in this one, A is -1, B is 3, and C is 0. So for part A, your vertex, to find the x, it's negative b over 2a. So that's going to be -3 over 2 times -1. -3 over -2 is 3/2. So that is the x value of the vertex. This is also your axis of symmetry. X equals 3/2. So to find the y value of the vertex, you need to put this into the equation. So here I go. Y equals negative parenthesis 3/2 squared plus 3 times 3/2. Remember, if you want to write 3/2 as 1.5, you could do that because that's what it is. So I'm just putting this into my calculator right now. Plus 3 times 1.5. So you should get 2.25. 2 1/4. That's okay to write as a decimal. Okay, for part C. Does it have a max or a min? Your A is negative. So that means this is opening down. So it has a max at your vertex of 3/2 or 1.5, comma 2.25. D. Does it open up or down? Well, we just determined it opens down because A is negative. Okay, A, B, C, D, E. Alright, so we have the domain. In all my previous videos, remember domain for all of these, this whole unit is all reals. F, your range. Again, if you watched my previous video about number 2, remember this is opening down, so it has a max, so all the y values are less than or equal to the y value of your vertex. G, your y-intercept. Well, remember the trick is, it's whatever C is, I get 0. So my y-intercept is at 0, 0. Now for some work for your x-intercept. So remember, our equation is y equals -x squared plus 3x. Whoops. So if you wanted to, you could do the quadratic formula, but when you're finding an x-intercept, remember, y is really 0. So if I look at this, and I could either factor, take square roots, but you can't take a square root because you have a b term, do completing the square or quadratic formula. I am going to opt to do factoring because I know that both of these terms have an x. I'm going to factor out a negative x. That's going to leave me with x minus 3. Zero product property. I have negative x equals 0, x minus 3 equals 0. This gives me x equals 3 multiplied by -1, x equals 0. So I have an x-intercept at 0, 0 and 3, 0. Alright, let's go to the graph now. Sorry it gets blurry. Alright, so our vertex was at 5, 1, 2, 3, 4, 5. Okay, so our vertex was at 1.5, 2 1/4. Okay, we also have our imaginary line for the axis of symmetry. I'm just going right down the line here of what we know. Our y-intercept is at 0, 0. Okay, let's use the axis of symmetry to our advantage. What is the distance from 0, 0 to the axis of symmetry? It is 1/2 and 1. It's 1.5. So what's 1.5 on the other side going to be? So if you're at 1.5 and you want to go another 1.5, that's going to bring you to 3. So notice those are also our x-intercepts, so I'm not going to graph those. So this is similar to number 2, where, remember, my requirements are that you have 5 points on your parabola and you only have 3. If you look at the video from number 2, I had to pick 2 values for x. In this case, you only have to pick 1, and then you'll flip it over the axis of symmetry. Again, you want to pick numbers close to your axis of symmetry, and you want to pick easy numbers, like you don't want to pick 3/4 or something silly like 2.5. Make it easy on yourself. So I'm going to pick 1 because I don't know anything about that. And I am putting it into the equation. Negative, notice how I use the parenthesis, plus 3 times 1. So it's going to be 1 squared is 1, make it negative, plus 3, so I'm going to get 2. Alright, so I have the point 1, 2. Use the axis of symmetry. 1, 2 is the same as 2, 2. I connect the parabola, and there is my graph.